In this video, we're going to be focusing on audio signal flow. This is one of those concepts that can be easily taken for granted because, well, we just sort of simplify things in our brain, right? We're going from real world sound and we're capturing it with a microphone and then we're getting it into a recording device like a computer or whatever. And we kind of miss all the little steps along the way, and there's really lots of them. So in order to have a firm understanding of just what's happening in the process, you need to sort of follow the audio signals on a little journey. So we're talking signal flow. Signal flow is the order of operations that audio signal is going to be going through. And if you think about it, it's really a lot more complex than just getting from microphone to computer. That's sort of like final destination, but there's oftentimes lots of little steps along the way and also little extra side trajectories where we might be sending audio. So we have signals flowing from a sound source into a recording device maybe, or an amplifier, and then things are getting sent around to different places, to headphones and whatnot. So this is sort of a standard map, what you're looking at here, of just exactly where audio signals are starting, where they go to, and maybe they circle back around. So let's break this down piece by piece, starting with the sound source, the thing that is making the sound, the real world compression and rarefaction, that vibration, that thing that's happening. Might be an instrument, could be a voice, whatever it is. The sound source is where the journey begins, right? So we're creating the sound, and then we're using a transducer like a microphone, and we're taking that physical energy, that vibration, and we're turning it into electricity that we can then send places and manipulate and do things with, right? Lots of different types of microphones that have different transducer types, different mechanisms that make the microphone do what it does, turning physical sound into electricity. But that's not necessarily the point here. The thing is that the real world sound is going to get captured by a microphone, turned into electricity, and that's really where the journey begins. Okay, from the microphone, that signal needs to go to a preamp, an electronic amplifier that's converting a weak electrical signal into a stronger output signal. So what it's doing is giving us an opportunity now in that signal flow to really manage the intensity of the audio signal. So we can use a preamp to raise or lower the gain levels that we're giving to those microphones and the signals that they're transducing. So we use the preamp and the gain level to, again, dial in the intensity level of the sound. From the preamp, we're going to go to an A to D converter, something that's taking the analog signal, right, the actual electricity, and turning that into a digital signal, ones and zeros that a computer can make sense out of. So we're converting analog to digital with an A to D converter. And there's lots of different brands out there. I use Avid Pro Tools, so I've got a picture of one of those A to D converters. We also then need to, well, bring in the audio into the computer. So we've changed the signal into a digital one. Now we need to connect that via USB or FireWire or some sort of cabling like that connects the digital signal to a computer, which then can be interpreted by a digital audio workstation, a DAW, right? Maybe it's Pro Tools, Ableton, Fruity Loop, whatever it is that you use, Adobe Audition. Eventually that signal is getting into the computer in digital form and being interpreted by the software. You can replace some of the steps here in our signal flow journey. You can replace the computer with something like an analog tape machine, where we're doing like reel to reel and recording that way, as opposed to a digital recording into a computer. You might also say, well, where is the mixer in all this, right? So sometimes the mixer gets skipped over in this process. You don't necessarily have to have a big audio console or a mixer, but it would be included somewhere along the signal flow if we were using one. Okay, and then monitor speakers, our output signal converted back into acoustic energy. So this is where we go full circle. We've made this journey that our audio signal is taking from real world sound source, right? The vibrations that are being caused. And we're going through all these steps, going through cables to a preamp and being intensified, and then getting into an analog and digital converter, going to the computer and the software. And then we're saying, well, you know what? In order for our ears to make any sense out of this, we need to change that signal back into an analog electrical signal that can then be produced into real world sound again on the other side of the engineer's glass, or maybe that's what we would use monitor speakers for. Maybe it's being amplified to a crowd from its stage, monitor speakers there, or maybe it's actually headphones instead of monitor speakers. Regardless, at the end of this process, we're taking that signal and we're bringing it back into real acoustic energy. So there we go. It's a short journey of signal flow. There's actually lots and lots of different pieces of that journey that might be unique to your specific recording setup, right? Depending on how complicated things are, maybe you need to, in addition to listening to the output signal by monitors in the engineering room, maybe we're also sending that to monitors for each musician or a headphone mixer or something like that. So each recording studio, each recording setup is going to have its own unique signal flow. But there's a quick overview on just how complicated that little journey can really be.